Okay, student, today inshallah we are going to start a practical paper again, and now this time the practical paper is related to a gate qualitative analysis and the qualitative analysis, and this paper is from May-June 2016. So as the beginning, this is a little description for all of you so that you can check what we are exactly going to do. Okay, and so going back to the paper, as I said clearly, this paper is the Cambridge International Examination A-level, and this is paper 3. You can see this is from Feb March 2016, and I'm solving the qualitative analysis on a special request from one of my friend, and this is related to qualitative analysis, question 2 of the same paper. So I'm directly jumping to the question number 2. Okay, so here you see this is question number 2. So here you will determine the concentration of hydrochloric acid used in question 1. So no need to worry about, just focus, as I discussed in my previous videos, while you are attempting these type of the question, please just focus the few common steps and no need to worry about. Okay, if you are in the practical, again no need to worry, you are all provided, and the main key feature is that you must have to stick to the method which examiner mentioned, and you have to properly follow. And again, what I said, do as directed. So whatever is directed in your exam, please do that. Okay, so don't do anything else, just do as directed. If you read this description, well, fine. If not, straightforward, go to the method and follow all these steps. Now you can see here he says that fill the burette, and as I clearly mentioned in my previous videos, just focus carefully, set up your apparatus, and what you can say, use the burette stand, burette clamp, and fit your burette there. Tap off, okay, close the tap properly, then place the filter funnel or the glass funnel provided and pour the given Fa4 into the burette. And you may not focus to fill it up till 0, as when you are focusing for filling it up till 0.00, it requires more attention and it will take time. Okay, so no need to worry about, just roughly fill it up. Where it goes, just stand for that, note it down, and consider that is your initial reading. Okay, you may write it down initially to anywhere, okay, with your pencil or the pen to any part of your paper. Okay, the rough titration, like rough initial value. Then he says that pipette 25.0 centimeter cube of Fa3, which is already given, labeled bottle with Fa3. Just take it out and use the pipette with pipette filler and carefully tap off the 25.0 centimeter cube into the conical flask. Then add about 10 drops of bromophenol blue. As I clearly mentioned in my previous videos, if the number of drops are mentioned, please do that. Again, do as directed. Never ever try to do anything by your own. Okay, always try to do according to the direction given. Do as directed, follow this pattern. So it is clearly mentioned, add 10 drops. If the number of drops are not mentioned, please don't exceed to 3. Okay, add 1, 2 or max 3 drops, no need to exceed. But here it is clearly mentioned, add 10 drops of bromophenol blue, as again it will be given in your exam, so try to focus. Okay, then perform a rough titration. Again, it's very simple. The procedure which I clearly mentioned, whenever you are going to do any titration, please give your result in a tabulated form. Okay, First of all, you have to mention the final final bill rate reading. After that, write it down initial bill rate reading, and then volume used. Okay, so you definitely have pencil, scale, so carefully draw. Okay, so this is the final bill rate reading, and must mention what? The unit, okay, or the scale which you are using to measure. So it should be in centimeter cube. Then initial bill rate reading, slash cm cube, then volume used slash cm cube. Now, as I clearly mentioned, try not to fill it your bill rate till 0.00. So you just have to, like in this case, I'm taking the initial roughly 7.65. One more important thing, that you may have to need or note it down any of the reading till 65, mean 05, 75, 35, any reading that contains 5 figure. Okay, then the final reading, right, let I can say the final reading is 32.85. When you get the difference, now I am using my calculator, and you can see I'm just taking a rough titration results. Okay, so it is 85 subtracted 7.65. So the answer I got is 25.20. 25.20. And always try to take the values in what you can clearly mention 2 decimal place, please, always. Okay, now this should be your titration, rough titration. It is 25.20. After that, what he says definitely is again a fixed pattern. You must have to take as many titration as you can, but remember, as in your exam, you're not going to do as many titration. Okay, so for this you have to remember the fixed pattern. Try to write it down at least 2 readings more with the difference of 0.2 and 0.1 with this rough titration. Whatever the rough titration is, try to take another 2 readings, and their difference must be till 0.2 and then 0.1. Okay, if you do this, this will be called as the accurate result. This should be called as what? The accurate titration result, and you can have to label them. Okay, oh, wait a minute. Okay, here another for the volume used, and then best titration results. So this is again same fixed pattern, final bill rate reading, and that must be measured in centimeter cube, so you have to mention slash cm cube. Initial bill rate reading slash cm cube, and then volume used slash cm cube. And as we are not going to take more readings, so no need to mention the best titration results. So here I can say so finally, as I clearly mentioned, you must have to take first reading with the 0.2 gap and then second reading with 0.1 gap at least. Okay, so if I make 0.2 gap, then it will be 25. The final reading definitely I getting 25.00, and here I have to take 0.00 and then 25.00. Okay, so as we are going to make these reading with the difference of 0.2, and 0.1. So no need to worry about how you are writing. Examiner is not checking that how you fill this paper table up. Okay, so no need to worry about. Just say now 24.90 with the gap of 0.1. So 0.00 24.90, and we are not going to perform any other titration. If you have enough time and if you are confident, you can do, but my advice, just take one reading very carefully and then follow the pattern which I suggested. Okay, forward. Then he says, from your accurate titration, as I clearly mentioned, what two results are considered to be accurate with a gap of 0.1 or less? These two readings must be considered as accurate results. So using those two results, which was 25.00 plus 24.90, we have to divide it by 2 to take the average, and the average will be 24.95. This should be the final volume that is used and is accurate volume. Now proceeding again, here the calculation part started. He says, see calculation, show your working and appropriate significant figures. Remember, always 3 to 4 significant figures are considered as appropriate figures. Must follow 4, okay? If not described or instructed, then follow 4. Then he says the final answer to each step of your calculation. So your final answer must be 3 to 4 significant figures. Then he says calculate the number of moles of sodium hydroxide present in volume of Fa4. We calculated the volume of Fa4, so we using the formula N means mole equals to volumes times concentration. Volume times concentration. So volume we obtained from the burette, which was 24.95. To convert this into dm cube, we are going to divide it by 1000. And now to check, to get the concentration, I'm going back and check what is the concentration of Fa4. What was the concentration of Fa4? So it is the burette Fa4, and where is Fa4? Here. The Fa4 is 0.100 mole of sodium hydroxide. So this was the initial information which was provided. So 0.100 was the concentration. I'm putting this value 0.100. 0.100. Now we have to get the answer, so I'm using my calculator. If I do this 24.95 divided by 1000 and then multiplying the answer by 0.1. So the answer I got is 2.495 times 10 raised to the power minus 3. Okay, so the unit is already mentioned, so you have to write your answer over here. Then he says use your answer to 1 like this and equation on page 5. And we know that I'm not going to page 5, as NaOH is monobasic, HCl is also monobasic or monoprotic. When these two react together, it produces NaCl and water. So both are reacting with 1:1. Okay, so when the mole ratio is same, moles always remains the same of one of the reacting or limiting substance. Understand? So we can say that how much moles of the sodium hydroxide used, that much mole of the HCl were reacted. Okay, so we can say as mole ratio is same, you can calculate. Okay, but writing this, just saying as mole ratio is same, so exactly the same amount, 4.95 times 10 raised to the power minus 3 moles will be the answer for the HCl in 25 centimeter cube. Then Then he says that use your answer to 2, like this answer, and any relevant information. When he says about any relevant information, it means that there is some information. We have to now read it out. So going back to the first information here. Here he says that Fa3 is a dilute solution of Fa1 hydrochloric acid. Fa3 was prepared by running 25 centimeter cube of Fa1 into a volumetric flask and adding distilled water until total volume of 25. So actually the Fa3 solution of the Fa3 was 25, and then from that 25 we pipetted out what? Here is the Fa3 25 centimeter cube. So out of this 250 we took what? 25 centimeter cube. So this is the main information. Now we are going to get the moles, convert the moles from 25 to 250. So first step is here the when we were using 25.0 centimeter cube solution, the moles of the acid were 2.49 times 10 raised to the power minus 3. But if the total volume which we diluted was 250 centimeter cube, then in that volume what was the moles of the acid present in total? So by cross multiplying we can get the value of X, or the moles of the HCl in 250 centimeter cube, like the answer I got in the previous section. Multiply that by 250 and divide it by 25. So the answer I got is 0.024. 0.02495. Even I'm going to write 5 significant figures, or even you can write it into the scientific notation, which should be 2.495 times 10 raised to the power minus 2. Okay, it was minus 3, now it is minus 2. Understand? So mean the actual moles were more than the reacted moles. So it clearly indicates that the acid was in excess. Okay, so now next question says show by calculation that hydrochloric acid in question 1 was in excess. Okay, so no need to worry about this, as we took the acid Fa1 from the question 1. Continued. So you remember, as I calculated, the total amount of the acid in Fa1 was this, but the Fa3 which we diluted and it reacted with the NaOH was this amount. So it clearly shows, these two readings shows that HCl was in excess. So I'm just going to write, if you calculate answers, that's fine, otherwise you just say that as the amount of HCl reacted is less than the amount or moles of HCl present. So less reacted but have more shows that acid is in excess. Acid is in excess. But remember, you must have to show your calculation from, or you may have to refer the answer in 2 and 3. Answer in 2 and 3 shows. Okay, so you may write this and this will be your correct answer. Proceeding. Now he says that D part, the error which we calculated in the previous question as well. The error in the volume reading of pipette is 0.06 plus minus. It may be increased or decreased, which gives a maximum percentage error of 0.24% for 25 centimeter cube Fa3. Then he says the error in a single burette reading is plus minus 0.05 centimeter cube. So then calculate the maximum percentage error in the volume of Fa4 used in B and deduce which solution of Fa3 or Fa4 was measured more accurately. Remember, Fa4 was measured by pipette, but Fa3 was prepared by diluting, by taking the solution of Fa1 and then diluting to 250 centimeter cube. So mean Fa3 was the volume, same volume, or we may use the volume we've calculated, which was 24.95. But remember, what is the maximum error that could be occurred in the reading of a burette? So it is 0.05. But we know that we read the burette twice while taking a single reading. So as to convert it into percentage, we have to multiply. So the answer I'm going to calculate again by using my calculator. It is 0.05 times 2. The answer should be divided by 24.95, and then to convert into percentage, multiply by 100, and the answer is 0.4. Almost the same answer which we got, which I remember in our previous video, which is 0.40%. So as you know, this 0.40 is more than this 0.24. So we can say the solution measured for Fa3 is less accurate. Okay, so it's the maximum percentage error of volume of Fa4. So we can say it is 0.40. Then was measured more accurately. Which was measured? The Fa3. Fa3 was measured more accurately. Remember, Fa3 was diluted and then used the pipette to transfer it to the flask, whereas Fa4 was filled in the burette. So this was the reading that we took by the for Fa4 using the burette, but Fa3 was measured by pipette, which is more accurate. So hopefully you know the information which I discussed fully. So if you have any problem, any question, you know the way how you contact me. And if you have further question, either you can contact on this number, or if you want little clarification, you may ask a question in the comment section. Hopefully you understand, and we'll see you in the next video. Till then, take care and wish you best luck for your exam, especially those students who are appearing for their Feb March exam. Okay, take care and bye bye.